Hey guys, welcome back to the channel. In the previous session, we have discussed some basic terminology which are useful for this course. In this video, we will be looking at exploratory data analysis and how to draw frequency distribution of certain variables. So moving on to exploratory data analysis. As we have discussed, EDA is a data exploration technique to understand the various aspects of the data. But you can't infer something from raw data. Raw data consists of a long list of numbers and labels that don't seem to be very informative. We use EDA to make sense of the data. Basically, exploratory data analysis consists of organizing and summarizing raw data, looking for important features and patterns in the data, looking for any striking deviations from those patterns, and interpreting your findings in the context of the problem. We will begin exploratory data analysis by looking at one variable at a time, also called Univariate Analysis. In this course, we will use NISAB dataset, which is National Epidemiologic Study of Alcohol and Health Related Conditions. This is a representative sample of US adult population age 18 and older, and it includes data on mental health and substance use disorders that are experienced by adults. As you can see, it's a large dataset which contains thousands of rows and columns. In order to get more clarification about the observation and variables in the dataset, we have a code book which will help us to understand what does the dataset represents. Now, as you can see in the left side, we have variables, and in the right side, we have information about the variable. Now, after understanding and exploring the codebook, I have decided that I want to explore the association between nicotine dependence and smoking behavior. In order to do so, I will look into the codebook and find appropriate variables which will help me to find my answers. For nicotine dependence, I have selected three variables to look at, which are tab_life_mdx, tab_bp12mdx, and tab12mdx. Similarly, for smoking behavior, I have three variables, check321, S3AQ3B1, S3AQ3C1. Since our codebook is also large, and in future, whenever we have to look at these variables, we can't be scrolling over the pages and wasting our time in searching them. So it's better to prepare a separate codebook which contains only the variables of your interest. So without any further ado, let's get to the code part. We will be using Jupyter Notebook to write our code because it can illustrate the analysis process step by step by arranging the stuff like code, images, text, output, etc. Here, as you can see on your screen, is the Jupyter Notebook interface. We will first start with importing dependencies. We will import NumPy and Pandas. NumPy and Pandas are one of the most common and widely used Python libraries. Every time you have to write a data science program, you will have to import both of the libraries. NumPy is an optimized library used for numerical computation, while Pandas is a data loader class. You can use it to deal with the data. In the next step, we have to load our dataset. First, we have to choose a variable to store the dataset. Let's say data. Then we will use the function read_csv provided by pandas. Then in the parentheses, we have to name our dataset by which it has stored in the memory or by which it has uploaded on Jupyter. We can also add another statement low_memory equal to false. Without low_memory equal to false, we may get a warning message because pandas try to determine what data type to set for each variable by analyzing the data in each column. So low_memory equal to false can increase the efficiency of our program. Now we will see rows and columns in our dataset. Print length data. It will show us the number of rows, and print length data.columns will show us the number of columns in our program. This step may take some time as we are loading the dataset. Now we have successfully loaded our dataset, and we can see here that the number of observations or number of rows are 43,000, and the number of variables or number of columns are 3010. Since our dataset has thousands of columns, so we need to make sure that all the variables are of same case. So we will uppercase all the variables. Now we will write data.columns. Then we will use map function, then in parenthesis string.upper, comma, data.columns. This will convert all the columns entries to uppercase. Now we will see frequency distributions. So to do so, we will select a variable, say C1. Then we will tell the Python to search in data. Then in square brackets, we will name the variable. Then we will use value counts function to show us the counts of the variables. Like all the other function, value count allow input inside the parenthesis. Here we include sort equal to false so that our data will be displayed in the order of the original values rather than sorted by the actual count. In the output, 0 represents no nicotine dependence and 1 represents nicotine dependence. We can clearly see that the higher part of the population is not nicotine dependent in the last 12 months. Now this was the counts of the variable tab12mdx. Let's see the percentage for the same variable. Code for percentage distribution will be same. We just have to add normalize equals to true after the sort statement. Here you can see approximately 88% of the population is not nicotine dependent in the last 12 months. Similarly, we can visualize the frequency distributions for any other variable. We just have to change the name of the variable. Now I will just copy and paste in the upper code, and I will just change the variable from C1 to C2. Then I will change the name of the variable. Let's say I have to visualize frequency distributions for check 3 to 1. Here in the output you can see 1, 2 and 9. These are the dummy codes. Here 1 represents smoked cigarettes in the past 12 months, 2 represents smoked cigarettes prior to the last 12 months, and 9 is the is the number of people who don't know they have smoked cigarettes or not. You may be wondering, what if I write sort equals to true after the value count statement? Let's see what happens. We will analyze the frequency distributions for the variable S3AQ3C1, which represents the usual quantity when smoked cigarettes. Here, inside the value count statement, we will write sort equals to true. As you can see in the output, it is sorted in decreasing order. Also, if you look carefully, you will note that the missing or blank category has been dropped from the output. To display the missing data, we will add drop any equals to false option to the value count statement. Now you can see the dropped or blank category has been revised with the name NaN. Now in Python there isn't just one way to visualize frequency distributions. We can also use group by function to display frequency distribution. Let's say we have a variable ct1, then we'll tell Python to look in data, then use group by function, then in parenthesis name of the variable, that is tab12mdx, then size function. Now I will print the variable, that is print ct1. After running the program, we can see the output is same as that in value counts method. For percentage distributions, we just have to multiply the above code by 100, and after that we have to just
divided by the length of the data. It will give us the percentage distributions of the variable. As you can see, the result is same by both the methods. Since our aim was to explore the association between nicotine dependence and smoking behavior, now if we think carefully, then we can see that in our data frame named as data, we have the population of all the ages and we have lifetime smoking status of that population. But what if some person has lived the cigarettes in some time? So in order to make our result or our association more efficient, we will focus only on young adults and only on those persons who have smoked cigarettes in the last 12 months. So we create a subset of the data named as sub1, in which we will only consider the young adults of age 18 to 25-year-old and the person who have smoked cigarettes in the last 12 months. We can do this by using the following code. Here I have chosen three conditions. The first condition is it should be the person should be greater than 18-year-olds, and the second it should be less than 25, and the third one represents the smoking status, in which I have chosen the person who have smoked cigarettes in the last 12 months. Now we will also create a copy of this dataset. So in future, if we make any changes in sub2, then our sub1 will remain as it is. As we have successfully copied and created sub2, now let's verify it by drawing the frequency distribution of age variable. Now you can use it either group by function or you can use value counts function. You can use any method. So for our ease, we'll use the value counts function here. Now as usual, I will tell the Python to look in sub2, then look for the age variable and draw the value counts of that. Now here I will use sort equal to false. You may use sort equals to true. It will just give you the result in decreasing order. I will just print the variable. As you can see in the output that the data frame is only of young adults of age 18 to 25-year-old.
That's it for this video. In the further video, we will look more for the data management techniques. And once we have successfully completed all our coding part, then I will share the complete code with you.